I want the camera.
Okay, so this is exam review day 1. I'll finish up tomorrow with the second half of the exam review. I'm going to go over questions 1 to 22 today. So if you've got questions on anything on the front side, you look like a floating head. I will answer them. Okay, so let's go. Let's start here with numbers 1 and 2. And again, I'm just going to kind of go through these. It would be a good idea for you guys to have out your exam review as well as the work. Make any corrections that you need to, because again, if it's covered on the exam review, it'll be on the exam. If it's covered on the exam review, it'll be on the exam. The first question here, solve the polynomial by factoring. Now remember that when I say the directions solve by factoring, if I say solve anywhere in the problem, that means that you need to give me an x equals in the end. Don't just factor it. I want you to solve by factoring. So when I go to factor this, the first thing I would do is take out the x to the third and also a negative 6, it looks like. So negative 6x to the third comes out, and that gets me an x squared plus x minus 6. Now that factors even more. So factors a negative 6 that I have to get to positive 1 or positive 3 and negative 2. So that means that each part of these, so if you left it here, I would still take off a couple points. Because again, that's just factoring, not factoring to solve. So I want to take it one step further. I want to solve this. Negative 6x to the third equals 0, x plus 3 equals 0, x minus 2 equals 0. And there are my 3 answers. 0, negative 3, positive 2. Okay. 0, negative 3, positive 2. Let's take a look at number 2. Kind of let the cat out of the bag a little bit first. Graph to find the zeros. I think I announced that in class anyway. I want to show you what I mean when I say graph to find the zeros. You go into your y equals, and you plug in x to the third minus 7x squared plus 14x minus 6. All right, so there's my polynomial. I'm going to zoom 6. And I see that it crosses, it looks like a couple times. It looks like it crosses a couple times. Remember that if you've got your calculator, and you will have your calculator for the entire exam, if you've got your calculator, you can take a look at where it crosses the x-axis and run those numbers through synthetic division. Now, how do we know that it's going to cross nicely at 3? Well, it looks like it, but you shouldn't always go by what it looks like. You can look at the table here to see that it indeed crosses nicely at 3. Look, I've got 3, 0. That's one of my intercepts. So you run synthetic division with 3. Now, this is the way I would do synthetic division here. You know, let me show that, because a lot of people were like, what, synthetic division? What? So you would say put 3 in the box and then line up your coefficients. Remember that you would have to leave a placeholder, right? If there was any terms not represented, you would leave a placeholder of a 0. So you drop down your first term, 1 becomes a 1, and then you take the number in the box times the number below the line. 3 times 1 is 3. Add down. 3 times negative 4 is negative 12. Add down. 3 times 2 is 6. You should always get a 0 if it's a root of the equation. Now remember, what that leaves me with is a polynomial, right? 1x squared minus 4x plus 2 with no remainder. Right? Those coefficients, those numbers that I get, are the coefficients on the next polynomial. So this x equals 3 becomes an x minus 3 as the factor. So we say x squared minus 4x plus 2. And you might notice that does not come out nice. That's not a factorable expression. So I have to use the quadratic formula. That's what you see peeking out down below there. Okay. I know, crazy, right? So my roots are... make sure you reduce that down. The radical 8 becomes 2 radical 2, and you reduce the entire fraction. Right? The inside the radical becomes just an 8, so it's 2 radical 2. Divide each piece by 2, both the left side and the right side of the numerator. So therefore, we've got a 2 plus or minus radical 2. You know, honestly, that would have been a good one to complete the square. Let's do it. Why not? We got some time. X squared minus 4x plus 2 equals 0. It's so much easier than doing the quadratic formula.
But I know the quadratic.
I didn't even know.
You get the my algebra 1 students know how to do this.
Okay, but they're in algebra 1.
They probably work at you in class.
We add the same thing to both sides. I call this the magic number. I say, what's the magic number, kids? And I'll say 4, which is the correct answer. Because you take half of b, -4, half of that is -2, and you square it, you get +4. And the goal of that is to make this thing factorable. So x minus 2 squared is equal to 2, square root it. X minus 2 is equal to plus or minus radical 2, and add the 2. Because I didn't even have to pick up a calculator.
No. How does one get from x squared minus 4x plus 4 to x minus 2 squared?
Because it's just factors. Factors of 4 that add to get to -4. Or you just think that that's always b over 2. Always. The formula does have a song, you're right. Okay, number 3, leading coefficient. Just as a reminder about end behavior. Just as a reminder about end behavior, that's the end behavior dance. So, positive, even, negative, even, positive, odd, negative, odd, right? And what am I saying there? Positive, even, positive, odd, negative, odd, right? And what does that mean? That's telling me what's happening on the far right and far left side of each polynomial. Positive and negative refer to the leading coefficient. Even or odd refers to the degree. So positive even means it's going to go up on both sides. Positive odd means it's going to go positive even, negative even. Positive odd means it's going to go up on the right, down on the left. Up on the right, down on the left. So leading coefficient is positive, degree is odd. So that means on the right side. And remember, the notation says this first phrase of the notation, as x goes to infinity or as x goes to negative infinity, all that's saying is on the left side, as x goes to negative infinity, as my x gets smaller and smaller and smaller, it will do, well, what will it do? It will go down. The function will go down. P of x will, oh, that's a plus sign. Here, hold on a second. There we go. As x goes to positive infinity, so that's on the right side, the function goes up. P of x goes to positive infinity. As x goes to negative infinity, on the left side, what's my arm doing? Going down. So the function goes down as well. Okay? Questions about that? Okay, let's talk about number 4. The maximum and minimum values are right there. Honestly, all you have to do is just plug this in your calculator and do second calculate maximum or second calculate minimum. And I just want the y values. I don't need the x values, just the y values. Anybody need to see me do that? Okay. Number 5 here, finding the inverse, using inverse operations. Again, all you need to do is flip x and y and resolve for y. So therefore, I just take x and y, flip it here. You get x is equal to y over 2 minus 3. And then I just resolve for y. Get y completely alone. Add the 3, multiply by 2. So it's either 2 quantity x plus 3 or 2x plus 6. Either way you want to write it there. It would not be okay to say 2x plus 3. Right, with no parentheses there. Because that was a very, very, very big mistake that I had a lot of people do on thinking back on this test. A lot of people tried to add the 3 before multiplying by 2. Multiply by 2 before adding the 3. You can't do that. Number 6, the regression. And you got to figure out what the polynomial would be. Remember that all you need to do is just plug these into list 1 and list 2. Right, go into your calculator, stat, edit. Remember where that is? Stat, edit. And then you have your list 1s and your list 2s. And then you just figure out which one has the best r value, r squared value. Okay? Looks like r squared value is at 1 at cubic and 1 at quartic. But if you check the 1 at quartic, the a value is 0, which reverts it back into being a cubic. Okay? So the cubic function is 11.16 cubed, or repeated x cubed minus 38x squared plus 141.83, repeating x plus 286. Would anybody like to see that process done? Yeah? You want me to go through that? Now, do we get the change, the x change? It said let x equal 0 correspond to the number of years since 1999. So since my first x value is 1999, that's why I start with 0. Okay, so let's go into my calculator here. I'm going to go stat edit, like I did. I'm going to clear down, clear down, clear down. Again, if you have calculator issues within the exam, I can help you. I can't teach you how to do something, but I can try to, whoa, not 45, just 4. But I can assist you with some technical issues. Okay. Now, I have to figure out which polynomial to use, so we go back out. Remember, we go stat, and instead of going to edit, I scroll right once to calc, and then I use the quadratic cubic quartic. Here's 5. Oops, 5. And we say, okay, r squared is 0.99, getting close. Run stat calc 6, and it's at 1. And I can stop once you hit 1. If you run quartic again, it will get you a 1, but your a value would be 0. So that's why you see the 11.16, the negative 38, the 141.83, and the 286.
Wait, how do you know which one
The highest r squared value. But if you land on something that's already at a 1, you can stop there.
Okay.
Because that just means the subsequent ones will be not wrong, it'll just revert you back. Look, a is 0. So when you go to say, y is equal to 0x to the 4th, that term will just go away. And then look, 11.16, negative 38, 141.83, 286. All right, let's jump back to the key here. Nope. Not necessarily. There's 7, 8, 9. That's just transferring from logarithmic into exponential and exponential to logarithmic. Don't forget the spiral, right? How do you transfer from exponential to logarithmic? If you've got log base b of a equals c, right? This is logarithmic form. You would say b to the c power is a. Base raised to the c power is a. And that transfers the other way too. Log base b of a is c. Spiral it around. Okay. Number 9, that one is kind of obsolete now. I think you can just do that in your calculator. Most of you can do that in your calculator. Except for Joy. Joy's the only one that has to do the change base like me. Yeah, all you got to do is do log 243 divided by log of 27. All right. Here is 10 and 11. There's 10 and 11. Remember subtraction. Remember the logarithmic rules? Addition of the logs is multiplication within the log. Subtraction of logs is division within the logs. And then, so we would have log base 3 of 27 minus log base 3 of 9, which will get us log base 3 of 27 divided by 3. First number divided by second number. So 27 divided by 3 is 9. Log base 3 of 9 is 2. Because 3 squared is 9. Number 11 was kind of interesting there. You want to try to get the bases the same. So since this is already a base of 3, we can make 81 as a base of 3 as well. 81 is 3 to the 4th. That is an equivalent statement right there, right? 3 to the 4th is 81. So I'm going to remove 81 and in its place write 3 to the 4th. Well, this means power to a power means we multiply powers. So I could really just write that 3 to the 4x, right? Once you do that, you can set the exponents equal. Once you get the bases the same, you can set the exponents equal to one another. X plus 15 is equal to 4x. And then just solve. Remember, when you're solving an equation, you can always plug your numbers back in to see if it works. Like you can say, okay, 3 to the 5 plus 15, is that the same thing as 81 to the 5th? Make it too big of a number. 81 to the 5th. Did your calculator do that? Nope, it'll do it. And that would be like 3 to the 20th. Yeah, same number. I think that's it on that page of the key. Yep.
For 11, what'd you get?
What?
I'm on the phone.
What's wrong? Yeah.
You just get rid of the 3?
Yeah, once you get the bases the same, you can set the exponents equal to one another.
Okay.
Yeah.
How do you put number 9 into your calculator again?
You just do, I can't show you on the board there because I don't have it, but if you go into math, it should be log base.
Oh. Wow.
Okay, any other questions through 11 before I skip to the next page?
I think we're good.
Thanks,
I
Luke.
speak for everyone else.
Okay, here is 12 and 13. Let's talk about 12 first. 12 is division. This is getting into chapter 8 now. Right, this is getting into chapter 8 now. This is all the fraction work is chapter 8. With this division, I've got 4x to the third over 9x squared y divided by 16 over 9y to the fifth. Remember, keep, change, flip. So that means that'll give me first term stays the same. The second term turns into 9y to the fifth over 16. And then you can start cross canceling. The 4 reduces down to a 4 here. The 9s completely cancel out. And then honestly, I would do this as well. X to the third over x to the second would be just x to the first. And then y over y to the fifth would just be y to the fourth on top. So that gets me an x to the first, y to the fourth, all over just a 4, it looks like in the very end. Yeah, cross cancel. Cross cancel. Remember cross canceling? When you're multiplying and dividing, you can cross cancel pretty easily. Now, 13. 13 is the more difficult problem. When I am adding or subtracting, okay, when I am adding or subtracting, do we need common denominators? Yes. Yes, you need your LCD. And to find out what your LCD is going to be, you factor both of the denominators. Well, it looks like the denominator on the right factors into x plus 8x minus 7, and the denominator on the left is already factored, x minus 7. So my LCD is all the factors represented. So my LCD is x plus 8, x minus 7. So you then look here and say, okay, well, that one doesn't have the x plus 8. So I need to multiply by x plus 8 over x plus 8. Which FOILed out gets me x squared plus 8x plus 1x plus 8. Which that's where I get this x squared plus 9x plus 8. This looks like an H right here. Sorry about that. The poor handwriting. So that's x squared plus 9x plus 8 plus your negative 12x minus 36, which simplifies down into x squared minus 3x minus 28. Which factors? The factors of negative 28 that as you get to negative 3 are negative 7 and positive 4. Negative 7 and positive 4, which makes the x minus 7s cancel. So I'm left with x plus 4, x plus 8. Make sure you write out what x cannot be. Remember, for that, you need to go back to your LCD and set that not equal to 0. So x plus 8, x minus 7 not equal to 0. That means x can't be negative 8 or x can't be 7. All right, taking a look at 14 here. 14, I've got 12 over x squared minus 4 is equal to 3 over x minus 2. My LCD in this case is an x minus 2x plus 2. Look, the left side factors down into x minus 2x plus 2. The right side already has the x minus 2, so all I'm going to do is multiply by x plus 2, numerator to to denominator, which means, look, I've got the 3 times the x plus 2, which essentially is a 3x plus 6. And once you get the denominators the same, you can set the numerators equal to one another. So 12 is equal to 3x plus 6, subtract the 6, divide by 3, x equals 2. But wait, there's more. 2 is not defined. Look back to your original. X cannot be 2 because of this x minus 2 in the left side. Left side of the denominator. So while 2 looks like it would be a solution, it's extraneous, so there is no solution to this equation. We got the answer up there to 15 as well. I just spoke to it. The fifth root of 243x to the 10th is 3x squared. Remember, you take the fifth root of 243, just make a factor tree, reduce it all down, look for a set of 5. 3. And then fifth root of x to the 10th, that's just division, right? X to the 10th, 10 divided by 5 would be 2, so x squared.
Oh. Yeah, good one, right?
16 should be pretty easy. Just putting it into fraction, a fractional exponent, that's just x to the 7/9.
Why?
Hold on.
Why would you do that then?
I left that one blank.
Remember, it's power divided by index, right? And when you're changing something from a radical to a exponent, it's base is equal, or base to the power divided by index.
Oh.
Okay.
Well,
I don't know.
I don't remember what
I mean, that was at the near the end of chapter 8, so it's right around spring break time. So maybe that was it.
That's so crazy.
Number 17. We have a transformation question for number 17. Let's go. Parent function f of x equal to square root of x is stretched horizontally by a factor of 5. You see the stretch horizontal by a factor of 5. Remember, horizontal stretch multiplies to the inside. So 1/5 x is on the inside. Then it's reflected across the y-axis, which will change the x value, making it negative x. So we got a negative 1/5 x inside. Then it's 4 units right. Now be careful here. If it's 4 units to the right, it must go in parentheses. Because when I'm transforming something, moving it left and right, I remove what's there, and in its place, I write an x minus 4. So that means the x has to go away and plug in as an x minus 4.
Gee.
If you did not have the parentheses there, I would take off point.
What? That's a tough one.
Because it would not technically be that transformation.
Wow.
If you didn't want parentheses there, it should have been negative 1/5 x plus 4/5.
Why does this gotta be so weird?
Sorry. All right, number 18. Number 18. Solving that equation, square root of x minus 9 is equal to x plus 1. All I do is square both sides of the equation, which would give me an x minus 9 is equal to x squared minus 2x plus 1. When I FOIL that out. And then I just solve. I subtract over the x and subtract over the 19. So negative 3x minus 18. Which factors? Factors of negative 18 that had to get to negative 3 are negative 6 and positive 3. So x equals 6 and x equals negative 3. However, 3 is extraneous. If you, negative 3 is extraneous. If you plug in negative 3, it's not going to work. On the left side, you get a positive 4. On the right side, you get a negative 4. That's not the same number. So negative 3 is not a solution. 6 is, but not. Because when you square something working with a rational or a radical expression, you always have to check your answer because solving it like this may get you a extraneous solution. So you get your two solutions of 6 and negative 3, but when you go to plug it, 6 plus 9 is 25, square root of 25 is 5. 6 minus 1 is 5, that checks out. But when you plug in negative 3, Negative 3 plus 19 is 16. Square root that, you get 4. Negative 3, because it's a negative, and I subtract the 1, that gets me negative 4. Which is not a solution. Doesn't check out.
Okay.
So only one of them is a solution. Just 6, not negative 3.
Always gonna be one answer?
What's that?
Is there always gonna be one answer?
I don't want to say always. Just double check. You've got 19 and 20 up there. The piecewise functions. This is the first question from chapter 9 in there. The composite or the composition chapter. Yes, sir. Yeah. So 19. If I want f of negative 4, this x value is telling me exactly where to go. Do you see how negative 4 is less than or equal to negative 3? Doesn't fit in the other two domains, but it fits in this one. So negative 4 is just 9. You don't even have to plug anything in. Usually, you have to like plug negative 4 into something and like run it as an equation. You don't have to do that. And then same thing here with 7. 7 is greater than 3, right? So it fits into those last domain. So it's just 5. 20, remember the boundary line is wherever this gets cut, right? So if x is less than 5, there's a rule for it. If x is greater than or equal to 5, there's a different rule for it. So, you could draw in your dotted line if you'd like to. Remember, there's a piece that goes on each side of that dotted line. They don't go both on the same side of the dotted line. There's a piece that goes on each side of the dotted line. This piece over here, negative 3, is less than negative 5. Horizontal line of negative 3. Positive 3 if x is bigger than 5. Notice that the closed dot is on the positive 3 because it's the or equal to. Again, you may be getting thrown off because we're not just, there's no equation there. You're just like, I don't know, just drawing a horizontal line. Okay. Anybody need that? Here's 21. Is this, wasn't this one like f minus g? Yeah, f minus g. So the only catch here is when you go to subtract it, make sure you use parentheses so that you can distribute that negative. Because it should have been a plus 3x minus 6. So you should have gotten a 6x squared plus 10x minus 9. And then is 22 multiplication? Yeah, 22 is multiplication. Same f and g? Nope, different f's and g's. Okay. So if I just want to multiply these together, you just got to FOIL it out. You just got to FOIL it out. 6 times negative 6 is negative 36, x cubed. 6x squared times times 4 is, we're doing it this way. 5x times negative 6x is negative 30. Negative 3 times negative 6x is positive 18. And then we bring it all into the 4. 6 times 4, 24. 5 times 4 is 20. Negative 3 times 4 is negative 12. And then you combine like terms. Okay. Questions on anything through 22? All right, I'm going to stop the video now, and then I'll pick up tomorrow for the rest of it.